Okay, so this number 44 is sort of interesting. Got some questions, not surprising. It's the part A isn't too hard, but part B is sort of fun, meaning it's a little bit hard. Jack and Jill, they're the only residents in a neighborhood. They'd like to hire a security guard. Jack values that at $160 a month. Jill values it at $150 a month. Guard costs $120 and will protect the whole neighborhood. Jack earns $6,500 per month. Jill earns $5,500 a month. Proportional tax on 1% of income. How much would Jack and Jill pay? So Jack would pay 60. Switch to my pen. Jack would pay 65. Jill would pay 55, and that would be enough. The 65 plus 55 is exactly 120. They've canned this problem. Now the B is fun, in the sense that it's another blast from your algebra past. Suppose instead that Jack proposes a payment scheme under which Jack and Jill would each receive the same net benefit from hiring the guard, and that presumably would be more fair, right? Or is at least one idea of fairness. And let's think of how to do this. Let's let X be what Jack pays, and Y be what Jill pays. So Jack's suggestion means that his valuation 160 minus his payment share is 160 minus X, and he suggests that should equal Jill's net benefit, which would be 150 minus Y. And at first it looks a little tough because we've got two unknowns in just one equation, but we also know that X plus Y have to sum to 120, so that Y is equal to 120 minus X. So that gives us an easy way to boil this down to just one equation and one unknown, and we know that would be solvable. So let's just substitute out for Y. 160 minus X is equal to 150 minus parentheses 120 minus X. Watch out. So I've noticed students are sometimes bad at distributing signs through parentheses. So watch what we're going to do here. 160 minus X is equal to 150 minus 120, that's 30. But 150 minus negative X, that turns into positive X. So let's add X to both sides and subtract 30 from both sides, and we get 2X is equal to 130. X equals, lo and behold, 65, canned problem. Y is equal to 55. So in this case, the proportional tax yields exactly the, maybe you guys have different numbers, but in my numbers for this problem, it's the proportional tax and the equal net benefit solutions are the same. Jack would pay 65, Jill would pay 55. They would both vote for the scheme, right? Jack values it at 160. It only costs him 65. Jill values it at 150. It only costs her 55. They're both in favor. Yes, both will vote for it. But in this case, it works out the same. But the problem of thinking about a fair solution, okay, everybody gets the same net benefit. That's true, but remember, we can't directly observe people's net benefit. And if people know that their payment shares are going to be tied to how they answer how much you value that service, this puts an incentive to lowball. Maybe Jack is, oh yes, it's worth 160 to me, but I don't want to pay my big share. It's worth, it's worth 110 to me, whatever. He can lowball, and knowing that he's driving down his payment share. So we don't have that option in real life. And so we use things like proportional taxes or even progressive income taxes based on the observation and the just stone cold reality that rich people are generally willing to pay more for just about everything. And they have more money. So Well, and if we're talking about government services like police and fire, they have more property to protect. But obviously, things like national defense, their share of the protection is just the same as a poor person's share of that. But their ability to pay is higher, and presumably their willingness to pay is higher as well. Okay. Obviously sometimes they'd be more willing to pay for some things and less willing to pay for others. We don't get to just pay taxes for what the government programs we agree with. We'd all have a different list, right? What is the practical problems? Let's see what we can find. Each party involved has an incentive to understate, to pay less of the total cost.